意思，那个有一个那个就是其中的那个评鉴哦，那个可以麻烦同学在下课的时候填，因为理论上你在填的时候不方便在现场，因为这个是等于说是对老师的评鉴嘛。那我不应该看到你们的分数哦，这个对，所以说如果可以的话，在下课填，好不好？那尽量不要耽误到上课的时间。那当然，如果对我教课有任何不爽的，欢迎公干哦。对，我们再等一下。
现在只针对
我要怎么用啊？再次提醒同学，我们下堂课是期中考，考试范围会在我们今天上的这个范围是上哪边，然后决定考试的范围。OK， 基本上从开学到今天上课上到。刚刚讲到那个评量哦，如果说同学后面才进来，还没有拿到那个评量的，下课再过来拿，然后下课再来填，好不好？ let me remind again, okay, for those who just came to the class, okay, we will have midterm next week in this classroom, okay. So the cover range will be from the beginning of this semester to whatever I finished today, okay. And yeah, there's a review for this class, okay, midterm review for this class. But I mean, if you already got a copy, great. If not, please get it like during the break, okay? And please fill out this review during the break, okay? Not in the class, because I'm not supposed to see your evaluation to me, okay? So if you have any concern with this class, okay, please, write it down in this review, okay? 比如说你们如果不喜欢 EMI， 你们也可以写 ，OK。虽然说 EMI 并不是我不是主推 EMI 的哦，那我是被逼的啊，但是我也要这里老实讲，就是如果你们对 EMI 觉得说，这个东西没有什么用，你们也可以写在那个里面，但是。我讲句老实话，学校应该是一定会继续往下推，因为这是政府的政策。OK， 那OK， so come back to this class. Okay, we finished last chapter last time. Okay, so today we are going to talk about a new chapter, okay, which is the previous chapter is about determinant, right? So this chapter is about vector space. So here is the outline, okay, of this chapter, okay. I think, okay, even though we haven't finished today's lecture, okay, based on my estimate, okay. We should be able to cover up to section 4, okay? And for section 5, section 6, I guess that we will do it like after the midterm, okay? After the midterm, okay? And other than the midterm, okay? Another thing to remind you, okay, is that okay, there will be a quiz, okay? The third quiz, right? Next to the midterm, okay, in the following week after the midterm， 就说有一个小考，第3次的小考会在这个 midterm 这个结束的隔一个礼拜，那。OK， 那 cover 的范围的话，会从第2次的quiz 到也是要到第2次 quiz 的结束的后面 cover 到我今天上课的 cover 的部分哦。那基本上我会给你们一个还是一样一些练习题。那这些练习题包含的，其实那个这个 quiz 3范围当然是在 midterm。也在 midterm 里面，所以说那个就是让我们知道一下 ，OK。那一般来讲 ，quiz 跟 midterm， 当然都是考题嘛 ，I mean similar， 但是有一些不一样，因为 quiz 的时间比较短，那基本上比较是概念的题目，那 midterm 的题目因为时间比较长，3个小时。所以基本上比较偏向是有一些计算的方向这样子 ，OK。And I think I have the TA uploaded a sample midterm to you guys, okay? on the E class，OK，、我有请助教上传了一个midterm 的范例给你们看一下哦，可能 cover 的那个 range 不一定一样哦，但是 you get idea，OK，how the midterm looks like，OK，、然后重点就是在说那个就是你看的是那个 sample midterm 里面的那个出题的那个 style，OK，the style，not necessarily like the problem because the problem will be different，OK， 问题一定会不太一样 ，OK， 我不会重复的出题哦 ，OK，OK， so here comes the vector space. Okay, the first one is about definition. So what is vector space? Okay, a vector space, okay, is a set. Okay, V be a set. Okay, on which two operations are defined. Okay, so in this set we will define two different operations. Okay, the first one is addition, the second one is multiplication， 就是加法跟乘法哦，就是 if the following actions are satisfied for every U V W， 任何三 V 的元素下面满足哦，那 every scalar， okay A B， then B is called a vector space， okay， 所以下面的这些如果都满足，那这个第一的集合，我们就叫 vector space。Okay, first one, U cross V will be V, so it's we call it a closure under addition。就任何两个元素，你把它加起来，在这个集合里面元素把它加起来，它还是在这个集合里。Okay, another one, U plus V equal to V plus U, the commutative。所以这个加法可以左右互换哦。And U plus V parenthesis plus W equal to V plus U plus W parenthesis. Okay, so this is associative property for the addition. Okay, 这个应该蛮容易理解。The fourth one, V has a zero vector. Okay. Such that for every vector, okay, U plus 0 equal to U. Okay, so this is the zero vector. Okay, and for each U in V, there exists negative U in V such that U plus negative U equal to 0. Okay. So this is like the inverse of the addition exists. Okay. So up to now, all this property involve addition. Okay. Now it's about the multiplication. Okay. So if you have a scalar of A with scalar A，scalar 就是一个数字哦 ，scalar 就是数字。A times U will also be V. So for any element， 就是 U 是任何一个 V 的 element， 你把它乘上一个倍数，随便乘上倍数，它还是在这个集合里面。所以 this is closure under scalar multiplication. Okay. And A times U plus B equal to AU plus AB. So this is distributive law. Okay. And A plus B parenthesis times U equal to AU plus BU. So both of 7 and 8 are distributive properties, but it's just a different thing. Okay. One is like the scalar multiplication to the addition. The other one is addition to the scalar multiplication. full multiplication. So both are satisfied. The V is a vector space. The last one, APU equal to APU. Okay. Well, okay, there's the one times U equal to U. So there are these 10 rules. Okay, if a vector space, if something is a vector space, we have all these 10 rules have to satisfy. Okay. So it's very, although we are not necessarily talking about vector. Okay, vector space is not necessarily vectors, and it could be something different. Okay， 所以我们叫它叫 vector space， 它们可以不一定是 vector，but you can always try to understand these rules by the vector。永远你都可以用 vector 的概念去比较容易的去了解这个 vector space， 好不好？像这10条的这个性质哦，你可以用这个 vector 这个怎么讲？就是 vector 有加法 ，vector 有 scalar multiplication， 对不对？那你可以自己检验一下，一般的 vector 是不是满足？不管是几维的哦，对啊 ，n 维的 vector 基本上都满足这些。OK， 但是我们后面就会讲到一些something different。OK， 这个就比较复杂。好。Examples. So for example, for any integers, okay, n greater or equal to 1, r to the power of n is a vector space. 就像我刚刚讲 ，r 的 n 次方基本上就是 n 维的空间哦，它一定是 vector space， 就是一般的向量。那这个应该蛮容易检验的，对不对？这些都是我们常见的，就是说向量的。会满足的东西哦，所以说这个不是什么太困难可以理解，所以这个例子大家不需要特别去讲。OK， 再来 ，OK 就是不一定是 vector 样子，它虽然不是 vector 样子，但是它们还是很像。这个另外一个例子 ，for any integer n greater or equal to 1, then n OK。n times n define a set of all n times n matrices. Then n times n is a vector space. 就所有矩阵的那个 n times n 这样子的大小的矩阵的集合也是一个 vector space. Okay. I think this is pretty straightforward because we know like okay. The matrix are similar to vectors, right? 矩阵相加也是让每个相对应的那个 element 加起来。那矩阵的那个就是你如果说乘上把一个 scalar 乘上一个矩阵，那你也是把那个 scalar乘上矩阵的每一个 element， 对不对？所以就是这些性质都基本上跟那个向量基本上是一样的。所以向量会满足的东西，矩阵当然会满足。只不过你要稍微提醒一下自己，零一定在这里面，所以零矩阵就是所有都是零的那个矩阵，也在这里面，好不好？要记得一下。向量后面当然也是一样。OK， so far so good, right? The next one is a more interesting example. Okay, that CAB define the set of all continuous functions on the range AB for any FG, okay, in that are satisfy this property, and this, C, okay, is a scalar, okay. We define f plus gx equal to fx plus g of x. And CFX equal to CFX. So it can be verified that CAB is a vector space。所以 vector space 可以是用像这样的那个function 哦组合那个集合哦。那function的集合，你们在以前可能比较少接触到 ，OK？ 那这个是连续的function，连续函数，连续函式啊，函式在 AB 这个 range 特别强调的 AB 这个 range 连续的函式。那我们回来看一下，就是说那个 if two functions are continuous, in the range AB, their addition must be continuous in the range AB as well, right? 就这两个 function， 它在 AB 这个范围是连续的，那它们加起来，当然在 AB 的这个范围还是连续的，这没有问题，没有问题吧 ？OK， 然后 function 的相加当然满足交换 ，OK。F plus G equal to G plus F, no question about that. And if you have three functions, F plus G plus another function equal to this is no brainer, right? 因为 function 的加法，一般的加法当然满足这种 commutative property, OK？sorry, associative property, OK？ 然后那 function 有没有 zero function 呢？当然有，对不对？对不对？那 zero function 是不是在 AB 这个 range continuous？ 是嘛？零的 function 如果零的 function， 在任何的范围都是连续，对不对？所以这个 CAB has a zero vector or a zero function, whatever you want to call it, okay? And for each U in V, okay, 任何的 function, okay, 连续的 function 在 AB 连续的 function, there exists negative U in V such that U plus negative U equal to 0. 如果这个 function 是连续的，那你它的 F, 它的 negative F 当然也是在 AB 之间连续，对不对？对不对？连续加一个负号，这个方选还是在那边连续，所以那你把这两个方程加起来会变成0，这个也是很容易可以知道的，对不对 ？OK， 然后 AU 与 B 这个也是一样，如果说一个方选在 AB 这个 range 是连续的，你把它乘上 A 倍，乘上任何一个那个 scalar， 它在 AB 这个 range 还是连续的。这个问题应该都可以接受。然后这个 A times U plus B equal to AU plus AB， 那这个分配率啊，不管是这个分配率还是这个分配率，对方选跟 scalar 来讲，当然这个都是成立的哦，都没有什么特别好讲。然后再来 ABU 等于 A times BU again， 这也是一个简单的事情啊。最后1乘上 U 等于 U。这还是一样，方选乘上 B， 当然会围绕自己。那这个那自己当然是在这个 AB 这个 range 连续，就不会有什么问题的。所以这整个都没有问题。所以 ，in other words, the set of functions that are continuous in the range of AB, okay, is set. Okay, is a vector space. CAB is a vector space. Okay, 所以这个应该是你们看到最不像 vector， 到目前为止最不像 vector 的东西，但它是 vector space. OK， 好，那接下来我们来看看。For any integer n greater or equal to 0, that Pn denotes a set of all polynomials with degree at most, and prove that Pn is a vector space. 就所有的多项式啊，多项式它的那个次方哦，小于等于 n 的，所有多项式的那个集合，就小于等于 n 次方的多项式的集合。那这也是一个 vector space。Can you 它就是function基本上很容易 satisfy 刚刚讲的这些，如果前面这些东西都有嘛 ，OK， 然后零的，因为 zero vector 就是零的function哦，零的function，因为它的 degree 是零哦，它也在小于等于 n 的这个 degree 的这个function其中里面，所以它这个还是在的，它其他的这些东西也是类似的，这应该蛮容易 verify， 你们可以自己试试看 ，OK， 这个问题应该还蛮容易接受的。那这个相对起如果说你们已经接受了 CAB 这个集合是一个 vector space， 那应该对这个 PN 是 vector space 这件事情，应该不会怎么太 shouldn't be too difficult to to take this idea， OK？ 好，再来 ，we have some theorems， OK？ If V is a vector space and U is an element in this vector space, then 0 times U equal to 0. Okay, we do not have this rule in the vector space. Okay, for vector space, we have 10 different rules for vector space. Can we use those 10 rules to derive the first one? For example, this is a scalar, right? This is 0 is a scalar. So we can say 0 is 1 minus 1, plus negative 1, sorry, plus negative 1. U, right? No question about that, right? Because it's a scalar. Everybody know about scalar, right? 就是一个数字嘛，数字加上它这个数字的反的negation， 当然是这不会有问题。那所以这个是一样的。And then, okay, because of the distributed property. 因为分散，所以我们有这个1乘上 u 加上负1乘上 u， so we have this, right? Right? And 1乘上 u, OK。会等于 u 嘛？那负1乘上 u， 你说负1乘上 u，OK， 那我们又跑出来第三个，这还没证，那怎么办？来，我们来看一下还有什么别的东西可以用。We have this, right? Where is it? 0 equal to u plus negative u, right? So that's what we know. Okay. And then, okay, this one first. So we know 0 equal to this one. Okay, and also 0 is this 0 times u, right? Okay, that's from where? This one. Okay, that's all. 0 times u equals to 0. Okay. So this one distribute u plus negative 1 u. Okay, so this one equal to this one. Okay, so if you both sides, get rid of u. Okay, negative u equal to negative 1 u. Okay, so we can derive this. Okay, and then, okay, obviously, once we have that, this one equal to this one equal to u minus u. Okay, or plus negative u. Okay. So we have the first one and the last one. So if u plus b equals to 0, then b equals to negative u. Okay. This one is it's so difficult to move around with就是跟你讲说，它的加法的反元素是唯一的就是 u plus b equal to 0。Then b equal to negative u. Okay, and we can say if u plus b equal to u plus w equal to 0. Okay, then on both sides. Okay, well, actually we have like 3. Okay, we add negative in there. So it will tell us u plus negative u plus v equal to u plus negative u plus w equal to negative u. Okay, and these two cancel out. So u v equal to w equal to negative. Okay. So the inverse vector, is unique, okay, for any element in a vector space. Okay. So that's the first section. Okay. Then we are going to talk about the subspace. Okay. Well, we have 5 minutes, so let's just talk about the definition of subspace. Okay. What is subspace? Okay. Once you have a vector space, 一旦假设你有一个 vector space, okay, then okay, S is a subset of V. Okay. First, it's non-empty and satisfies the following condition, then S is called a subspace. 所以第一个，我们讲 subspace 一定有一个 vector space。OK， 那是它的子集哦，是这个 vector space 的子集。然后第一点它 is not empty。OK， it's not empty. Well, actually, any vector space is not empty as well. OK， 任何的一个 vector space 也是非空的，为什么？因为至少没有零，至少那个 zero vector is the vector space， 所以任何 vector space 都是非空的。提醒大家，事实上最小的 vector space 就是零开始，验证一下零这个几个它是满足所有刚刚讲的这些 vector space 的话。So okay, so if you have a subset from a vector space, okay, we have to satisfy the following 2 conditions to call this subset subspace. Okay, the first one is for any vector u and v in this subspace, their addition is still in this subspace. Now, the addition has the closure of addition is in this subspace. 就是你加法有这个封闭性，在这 subspace 的封闭性。And then for any scalar a and vector u, a times u is in this subspace. 所以说也是一样，就是 scalar 的乘法对这个 subspace 也是有封闭性的，也是有封闭性。对，满足这2条性质，其他的就不需要再去验证，因为其他的基本上一定满足。OK， 你知道意思对？可以知道说它是这个 vector space 这个是不是 subspace？ OK， 所以 according to the definition, to verify whether a subset of vector space is a subspace or not, we should verify the closure of addition with scalar multiplication. 这2个 closure 有没有封闭性？只要这2个封闭性存在，就知道这个 vector space 的子集合是 subspace。记得哦，你的这个 superset 一定要先是 vector space， 我们才能够讨论它的子集合是不是 subspace。如果它前面的那个 vector space 根本就前面的那个 superset 根本不是 vector space。你是不需要去讨论它的子集合是不是 subspace，OK？ 好，那 for vector space v and 0，OK， 就是with this only this R is subspace， 这2个是它的这个 subspace，OK？ 所以 0 is called a zero space，OK？
事实上，zero 不但它可以自己是一个 vector space， 它还可以是它自己的那个 subspace。OK， 那个我们通常叫 zero space。Any subspace D intersecting D itself is called a proper subspace。就是把 D 去掉，因为如果说是 D 其实它自己的 subspace， 但是你把 D 去掉，意思说你找比它小的，我说小就是说集合大小，比 D 的集合小一点，满足这个 subspace 的意义，叫它的 proper subspace。You know that zero belongs to any vector space subspace。好，所以这些性质，就是我们定义什么是 subspace。那接下来我们要讲一些例子，就是我们先休息10分钟，好不好？我们休息一段时间之后回来。那在那个下课的时候，如果你们没有已经拿到那个其中的那个问卷哦，请开始填。如果还没有拿到，请到前面来，助教会发给你，好不好？